In the realm of software development, quality reigns supreme. Two cornerstones of software quality assurance, or SQA, are verification and validation, commonly referred to as V and V. Verification, often dubbed building the product right, focuses on ensuring that the software is developed in accordance with the specified requirements and design specifications. Think of it as meticulously inspecting the blueprint of a building before and during construction. Validation, on the other hand, is about building the right product. It seeks to confirm that the developed software aligns with the actual needs and expectations of the users. Both verification and validation are essential for delivering high-quality software that is reliable, robust, and user-friendly. By adhering to these practices, development teams can cultivate a culture of quality, fostering trust among stakeholders and delivering exceptional software products. Section 2. Verification, inspecting the blueprint. Verification is an integral stage in the software development lifecycle, focusing on evaluating the software artifacts, such as requirement specifications, design documents, and code. This meticulous process is akin to scrutinizing the blueprint of a building before and during its construction. The primary objective of verification is to detect and eliminate defects early in the SDLC, preventing them from propagating to later stages. By identifying and rectifying errors in the initial phases, development teams can mitigate risks, reduce development costs, and ensure that the final product adheres to the desired quality standards. Verification encompasses a range of activities, including reviews, walkthroughs, inspections, and static analysis. Through these rigorous verification processes, potential defects are identified and addressed proactively, laying the groundwork for a robust and reliable software product. Section 3. Delving into verification activities, code reviews. Code reviews stand as a cornerstone of the verification process, providing a structured and systematic approach to scrutinizing the source code for potential defects. This practice involves a team of developers, often peers, meticulously examining each other's code to identify errors, inconsistencies, and deviations from coding standards. The primary goal of code reviews is to enhance the quality of the software by detecting and correcting defects early in the development cycle. By having multiple sets of eyes on the code, the likelihood of catching errors that might have been overlooked by the original developer increases significantly. This collaborative approach fosters a culture of shared responsibility for code quality. Furthermore, code reviews serve as valuable learning opportunities for developers. Junior developers benefit from the experience and insights of their senior counterparts, gaining a deeper understanding of coding best practices and design principles. Section 4. Further verification activities, static analysis. Complementing code reviews, static analysis emerges as another potent tool in the verification arsenal. This automated technique involves examining the source code without actually executing it, meticulously scrutinizing it for potential defects, vulnerabilities, and violations of coding standards. Static analysis tools act as tireless code inspectors, capable of analyzing vast code bases quickly and efficiently. They excel at detecting common programming errors such as buffer overflows, memory leaks, and null pointer dereferences. Moreover, static analysis tools can enforce coding standards and best practices, ensuring consistency and maintainability across the code base. By integrating static analysis tools into the development process, teams can automate a significant portion of the code review process, freeing up developers to focus on more complex and nuanced aspects of software design and implementation. Section 5. Validation, testing the waters. While verification focuses on the building it right aspect, validation delves into the crucial question of building the right thing. This phase in the SDLC shifts the focus from internal consistency to external conformity, ensuring that the software aligns with the user's needs and expectations. Validation is akin to testing the waters before diving in. It involves evaluating the software in a real-world or simulated environment to determine whether it meets the intended use cases and fulfills the user's requirements. This is where the rubber meets the road, as the software is put through its paces to assess its functionality, usability, and performance. Unlike verification, which primarily involves static analysis and reviews, Validation relies heavily on dynamic testing methods. Through rigorous validation, development teams can gain valuable insights into how the software performs under real-world conditions, identify potential usability issues, and ensure that the final product meets the user's needs and expectations. Section 6. Exploring validation activities, dynamic testing. Dynamic testing takes center stage in the validation process, providing a hands-on approach to evaluating the software's behavior in a dynamic environment. This involves executing the software with various inputs and observing its outputs, responses, and overall performance. There are numerous dynamic testing techniques, each with its unique strengths and areas of focus. Unit testing, for instance, focuses on verifying the functionality of individual units or components of the software in isolation. Integration testing examines how these individual units interact with each other, ensuring they function harmoniously as a cohesive system. System testing takes a broader perspective, evaluating the software as a whole, integrated system within its intended environment. Dynamic testing is an iterative process, often involving multiple rounds of testing and bug fixing. Section 7. Gathering user feedback, the human touch and validation. While dynamic testing provides valuable insights into the software's technical robustness, gathering user feedback injects the crucial element of human perspective into the validation process. User feedback can be gathered through various methods, each offering unique insights into the user's experience. Alpha testing involves releasing the software to a select group of internal users or trusted external stakeholders who provide early feedback on its functionality, usability, and potential areas for improvement. Beta testing expands the user base, releasing the software to a wider audience of real-world users. This provides a broader range of feedback, uncovering issues that might not have surfaced during internal testing. User feedback can also be gathered through surveys, questionnaires, focus groups, and direct user observation. By actively incorporating user feedback throughout the validation process, development teams can create software that is not only technically sound, but also user-centric, meeting the needs and exceeding the expectations of its intended audience. Section 8. Verification and validation across the SDLC. Verification and validation are not isolated activities relegated to specific stages of the SDLC. Rather, they are integral processes woven into the very fabric of the software development lifecycle. During the requirements gathering phase, verification focuses on ensuring that the requirements are clear, concise, complete, and testable. Validation involves engaging with stakeholders to validate that the elicited requirements accurately reflect their needs and expectations. In the design phase, verification activities revolve around reviewing design documents, architectural diagrams, and user interface mockups. Validation during this phase might involve usability testing of prototypes or mockups to gather early feedback on the software's design and user interface. As the development progresses, verification activities intensify, with code reviews and static analysis taking center stage to ensure the codebase's quality, consistency, and adherence to coding standards. Section 9. The synergy of verification and validation. A holistic approach to quality. Verification and validation, while distinct in their approaches, are not mutually exclusive. Rather, they complement each other, forming a synergistic duo that underpins software quality assurance. It's not about choosing one over the other, but about leveraging the strengths of both to establish a robust and comprehensive quality assurance strategy. Verification, with its emphasis on inspecting artifacts and adhering to standards, acts as the foundation upon which validation builds. By ensuring that the software is built right, verification sets the stage for validation to effectively assess whether it's the right product for the intended users and purpose. Validation provides the crucial feedback loop that informs and refines the verification process. This iterative interplay between verification and validation fosters a continuous improvement cycle. By embracing both verification and validation, development teams can establish a holistic quality assurance strategy that addresses both the internal consistency and external conformity of the software. Section 10. Conclusion: elevating software quality through rigorous V&V. In conclusion, verification and validation stand as indispensable pillars of software quality assurance. Verification ensures that the software is built right, adhering to specifications and standards. Validation validates that the right product is being built, meeting user needs and expectations. These processes complement and reinforce each other, forming a synergistic duo that underpins a robust and comprehensive quality assurance strategy. By embracing both verification and validation throughout the SDLC, development teams can elevate software quality, reduce defects, and deliver exceptional products that meet and exceed user expectations. In today's competitive software development landscape, organizations that prioritize and invest in rigorous V&V processes gain a significant competitive advantage.